Okay, today I'm just doing a quick catch-up of where we've been so far. We've been doing arithmetic and geometric sequences. The ones in red, those are arithmetic sequences. The ones in black, those are geometric. And you should be able to tell me, like, any random term. You should be able to write a sigma for these. And if I tell you a term, you should be able to figure out whether it was the fourth term or the ninth term, etc. All right? And I want to give you a few minutes to answer these. If you understand all of these, you are totally caught up at this point. And then today I'm going to give you a formula that helps you to actually add all of these. There's a formula for actually adding up all 17 terms or all 10 terms instead of having to do them one by one. Okay, pause for a second. Let me give this a try. All right, a sub n equals a plus n minus 1 times d. If you didn't have that formula, you could have kind of like used a calculator and hacked your way through this, but the ones we have on the test, you won't be able to. You'll have to use that formula. Okay, so now I'm going to put the numbers in the right spot. A sub n would be the, well, we want the 17th term, right? So 17. A is the starting amount, 2. 17 minus 1 is 16 here. So this is 2 plus 16d. And what's d? Oh, it's the difference. How much is this bigger than that? So I take 9 minus the 2 and make 7. And so 7 is the common difference. So it's 16 times 7 plus 2. And that would be 70 for the 7 times 10. 7 times 6 is 42. 112. 114? Raise your hand if you had 114. Awesome. Okay. A sigma. Here's the sigma. I'm going to kind of slide this down so you can still see the questions, but I have some room. Sigma. And I always just use the formula again. That's why one of the reasons the formula is so powerful. And what's my A? My amount. My amount that I start with is 2. And my n, I need an n because these numbers that go here and here will go in the n spot. And the d is the difference in that one we figured out was 7. So that's the right answer. If I go from 1 to 17 terms, 1 to 17. Raise your hand if you had that one right. Awesome. I just taught it yesterday, so I wouldn't be surprised if a few people had trouble. There will be a kid who multiplied this all the way out and thought they had to. If you did that, it would be 7 times the n is 7n, and then negative 7 plus the 2 is negative 5. 7n minus 5. It's the same. It's not any better. It's allowed. Okay, next. 72 is the blank term. Once again, I'm going back to the formula. A sub n is 72 this time. 72 is the nth term. A sub n in this formula is 72. And A, the amount we started with, was 2, plus n minus 1. Do I know what n is? No, that's the point, trying to find n. And the difference was 7. And then save me some time on that one. If you multiply it all out and solve for n, you get RS. What'd you get? N equals 4? N equals 11. Raise your hand if you had 11 on that one. That's almost everybody. Nice work. Okay. It's the 11th term. All right. Now, these black ones are for geometric. We need a different formula. I'm going to slide this one down to make myself a little more room. So this formula is A sub n is A times R to the n minus 1. Got that one down? Now I'm going to go put in the numbers. What's the amount? A that I started with? 2. What's the R, the common ratio? That divided by that, or that divided by that, same thing. It's 2. And then to the n minus 1. And then if I want the 10th term, I know n is 10. And that's 10. So A sub 10 is the 10th term. Would be 2 times 2 to the 9th. But I made this mistake last hour. I went 2 times 2 is 4 to the 9th. You can't do that. 2 times 2 to the ninth is different because the 2 to the ninth has to be first. That's a really big number. And then I times it by 2. 2 to the biggest one I know is 64. So is this one, is it 264? Or is there one more after that? I don't know. Somebody do 2 to the ninth times 2 and tell me what you got. 2 to the ninth times 2. 1024? Yep. All right. Does that include the times by 2 part? Okay. Can anybody verify 1024 as your answer? Okay, awesome. All right. The 10th term would be 1024. So this does remind me of when computers used to have a 2 gig hard drive. And then they came out, they started selling 4 gig, 8 gig, 16, 32, 64, 128. See what I'm saying? It's always doubles. That's Moore's Law. I'll tell you about that someday. Basically, it says about every 18 months, I wish it was as clean as every 2 years, it doubles. It was like every 18 months, the amount of memory that you can get on a chip doubles. All right, so anyway, 1024 would be after 10 doubles. And it just keeps growing. And that's why 1024 crossed over from, first from gigs, or from megs to gigs, and then from gigs to terabytes. And after tera, remember me telling you what the next one is after tera? Peta. Yeah. All right. It won't be too long. In fact, we could even figure it out using Moore's Law of when computers will be standard sold with a petabyte of memory instead of a terabyte. Right now, it's just becoming pretty common to be a 1 terabyte. I mean, I know there's some that have 2, but most computers seem to now have a 1 terabyte. Now, some computer companies are going the other way. They're making their computers have solid-state drives, which are much faster. They're like super quick, like instant-on computers. How many of you actually have an instant-on computer at home? You like flip it open and it's on. Okay, I just bought one recently too. And the SSD drives make that possible. They're like super quick memory. And so they're going with smaller drives but way faster. The idea being you store your main stuff in the cloud. See how that's changing it too? Because most people have a cloud account now, either through Google or through whatever. Okay, so enough about Moore's Law, but this last one, sigma for the first 10 terms on this, I had never taught you this. We'll see if you figured it out. It was the formula, of course, and this is for this series with the 2, 4, 8, etc. So that one is geometric. So hopefully you remember to put the formula for geometric. How many of you started with that? That was smart. Then you stick in the numbers, like A was 2, the starting number was 2. And then our common ratio, was 2 to the n minus 1. And then we needed from 1 to 10 to be the first 10 terms. You can say n equals 1, you can say I equals 1, or you could just say 1 down there. And I'd be okay with any of those 3. Any questions on that sigma? All right. Then you're ready, and this one's a pretty easy day today. I just get to tell you how to actually add up the first 10 terms of this without having to find all 10 terms and add them all together. There's an app for that. There's a formula for that. And this is one of my favorite math history stories. It's a true story. And little Friedrich Gauss was a little German boy who was very good at math. He turned out to be a mathematician, and he was one of the top greats of all time. But when he was a little kid, you can imagine, like he was probably pretty good at math, right? Well, his teacher was trying to keep him busy. They were in a one-room schoolhouse where you have some kids like learning, high algebra stuff because they're the older kids, and you have other kids that are learning just to add and stuff. And he was one of the little kids. I can't even fathom what that would be like to teach that nowadays. Although I hear there are still some super small schools like that, like in way remote Alaska, etc., where you might have only 8 kids in the school. So when you have math class, the teacher's trying to teach this kid calculus, and that kid pre-calc, and this other kid literally could be learning to add. It'd be just such a weird thought to have that class. Anyway, so Friedrich's in this little classroom with other kids, and he's pretty smart. this teacher says, how about you just add up the numbers from 1 to 100? Okay, I'm like, that'll keep him busy for a while. And he goes back there, and like 15 seconds later, he goes, I got it. And she's like, 15 seconds? There's no way you added up all the numbers from 1 to 100. And he figured out a new thing, which by now, a lot of people kind of know that little pattern. I shouldn't say a lot. In this room, I bet there's 4 or 5. If I asked you, because some of you might have just simply memorized the answer for that question, I'm going to tweak it slightly. Let's say I was going to have you add up all the numbers, 1 plus 2 plus 3, dot, 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 all the way to 200. How would you do it? There's a way. Who thinks they know the way? Because you remember hearing this story in the past, or maybe you're Friedrich. Yes, it's possible. What do you think? 200 and the 1. Okay, you add the first and the last, and that makes how much? 201. And then what? And why would just the first and the last mean anything? Do one more for me so people can see what's going on. And the 2 plus the 199, and what's that make? 201 also. See what's happening there? Do you keep doing that? Do you get every number can be paired up with another number like that? It's not going to just stop working. What's the next one down here? 198 plus 3. What's that make? 201. See that little pattern? Math's all about patterns. So little Friedrich figured out that you just add the first and the last one, and that would be 201. And then you times by, and what do you think it is? Times by 100. Why? Because there's 200 numbers, and yet we don't want to do this 200 times, right? So we do it half that number of times, which would be 100. Watch how easy it is to do in your head. When you times by 100, just move over the decimal a couple spots. 20100, boom, 20,100. That's what it adds up to. That makes sense to you? We added the first plus the last, and then multiplied by half of how many numbers there were. Now I'm going to go back and morph this formula for you to see where it comes from. Do you get this? 100 was half of how many numbers there were. If n's how many numbers you have, what do you think the formula says? N divided by 2. Next, this was the first number plus the last number, right? 201. Wasn't it made up of 1 plus the 200? Well, it's not always going to be 1. So what do we use for the formula for the first number? The first number. We have a letter for that. No, what do we always use for the first number? A. And how about the last number? It's not always 200, but it's always going to have to follow the formula. Once again, I say the formulas are a big deal, because if I just slap in that formula for this, that's how you find the last term. The nth term would be a plus n minus 1 times d. And now I'm going to go back. If this was my formula, do you get why the math book puts the a's together and says 2a? I mean, it is a plus a, right? But I don't think you should, because I think it's harder to memorize that. I think if you just remember it's the first number, by now you should have learned our first amount is always a. And then our last number, that's just the formula you already memorized, you already used to. And then you times by half of how many numbers there are. You could memorize that? That's not that bad. Otherwise, here's what you're going to see in the book. It's the same thing, just rearranged. And they put the a's together and they say 2a. So you can either moan about how you have to memorize another big formula, or you can just remember it's the first number plus the last number times half of how many that there are. I personally would rather memorize the blue way, because it's got the first number and the last number and then half of how many numbers we had. Okay. Now there's one more formula that you're going to need, and I'm going to have to, I can regurgitate it, I've got it, but I want to not make you write it down right now. I want to show you where it is so that you have to look it up later. You can find it. Today's lesson is 9.2, day 2. And if you scroll down to this yellow page, it's got the formula on this page. In a moment, I'm going to ask you to show me that you are there. This is under today's date. (9.2) day 2. Here's the formula I just showed you a second ago, except I wish that this 2n, or 2a, sorry, was broken into a plus, and then this one, that's your other formula, a plus n minus 1 times d. That way it's the first number plus the last number, and that's half of how many there are. The geometric one is much less intuitive. One thing I can tell you, almost all the formulas start with a. It starts with a. This is formulas. This is for a geometric now. A times 1 minus r to the n all over 1 minus r. If you wanted to look for symmetry, it's not that bad. It starts with the starting amount. That's nice. 1 minus r over 1 minus r. If it was really that, do you get that would just cancel and it would just be a, and that wouldn't make any sense? All you need is one more thing, though, to the end. And now, it has a little caveat after it. If r is not 1, think about it. If your common ratio was 1 and you started with 8, do you get that that would be this? You know what I mean? It's just an 8 over and over and over again. If r equals 1, it's not much of a arithmetic or a geometric. It's like a stays the same sequence. So they don't allow r equals 1. I mean, another way to say it is, this formula will just break down. You put in a 1 and you'll end up with a 0 on the bottom. That's not good. Can't get an answer then, right? So this formula won't work if r is 1. All right. So there's your formula. Let's see if you can figure it out. If I start with 3 and I keep doubling, but do I do it forever? Think about it. If it's going up really fast and I'm trying to add them forever, do you get the answer would just be infinity? So this is a very distinct amount. It's like you've got to do it n times. So if I have a series, it's got to be like this. 3 plus, now I'm doubling it, 6 plus, now I'm doubling it, 12 plus, and I want to do that for the first, let me think, 5 terms. What this formula does is it adds the 5 terms. I've given you the first 3. Use the formula to get the sum of the first 5 terms. Can you slip your phone into the backpack, please? Okay, here's how you'd use it. You stick the a is the starting term, and it is 3. And then 1 minus r, what was common ratio? I just always take that divided by that. And then if I'm feeling extra careful, I'll divide this one divided by this one just to make sure I did it right. 6 divided by 3 is 2, and 12 divided by 6 is also 2. So r must be 2. And last but not least, to the power of n. N is how many terms you have? 5. There it is. 3 times 1 minus 2 to the 5th. 3 times 1 minus 2 to the 5th. 2 to the 5th is 32. 1 minus 32 is negative 31. all over 1 minus 2. Well, that's kind of nice at least. 1 minus 2 is negative 1. And that just cancels off the negative. So it ends up being 3 times 31. I can do that in my head. 93. Unless I messed up, which is humanly possible. Can anybody verify they got the same exact thing? Okay, good. All right. That's how you use the formulas. Now, what if it's a word problem? Well, it's just going to be like this. Billy is saving $5 this week. He's working like he's doing odd jobs, okay? He saved $5 this week, $10 next week. Now you got to like see if I'm going to be realistic or not. If he doubles how much he saves each week, do you get pretty quick he's never going to be able to keep that up? $5, $10, $20, even that's all possible. Then it's $40 a week. And then it goes to $80, then it goes to $160. It can be pretty tough to earn that much. So the word problem might be more likely to be he saves $5 more each week. So he saves $5 this week, $10, $15 next week, 20, 25, 30, 35, 40. And that even could break down eventually, but at least it's only going up in a linear fashion, as in a reasonable straight line rise. So anyway, that could be a word problem. And then I could say, how much does he have at the end of 30 weeks? Get how that word problem all of a sudden turned into a sequence problem? All right, we're going to do it. You ready? Get to a blank page so you can write this down. He saves $5 in week 1, $10 in weeks 2. Write this down. It'll help you stay awake. I know it's kind of warm in here. And on flannel day too. It's extra, everybody's, not everybody. People that are wearing the flannel are extra warm. $15 week 3, etc. You don't have to keep writing them. Let's see how much money he has saved total, not how much did he save in the 30th week. My question is, how much total did he save? As in week 1 plus week 2 plus week 3, blah, blah, blah. 30 weeks. Just for perspective, that's, it's like a school year if you take some weeks off. Take a week off for Christmas, or a couple weeks off for Christmas time, maybe another week for spring break. You could have 30 weeks of school. So that was a word problem, yet it turned into a sum of a series question. Tell me what you did. And then, okay, what's the equation? Actually, what's the raw form of the equation before you stick the numbers in? Just the raw form. AN equals A. There you go. But that formula just tells us the last number. Okay? But is the last number important? Oh, yes, it is. So let's use this and figure out the last number. Then you'll have the first number and you'll have the last number, right? Okay, so let's use this to figure out the last number. I know some of you are thinking, there's another formula. I know, there is, and we could use that. But I think it's okay to think, okay, 30th term. Do you get I can find that using this formula? I go 30, and amount to start with was 5, and our common difference is 5. And so this is amount 30 will be 5 plus 29 times 5. And that is basically 30 times 5. And that's 150? Help me out. Is that the right number at the end? Okay. So the 30th term would be $150. Now, that's not what I really asked. What I asked was, how much do they all add up to? Not how much did he save in the 30th week. What do they all add up to? That's a different formula. And it goes like this. N over 2 times the first amount, which we know, plus the last amount, which we just used this formula to calculate. So we just did all this, and we got 150. Our starting amount was 5, and then that makes 155, and we times it by, ooh, again, I'm trying to show you real world. I didn't just, you know, like, stick the numbers in the formula. I got like think it through. N is how many terms there were, which was 30. Said so right here. So 30 terms divided by 2 is 15. 15 times 155. I have no idea what that is, but how many of you came down to that? It came down to 15 times 155. Awesome. Do you happen to, did you use a calculator and figure it out yet? Could you, Caroline? I appreciate it. Anybody verify that? All right, 2325. Now let's back up and talk about what that is. That's how much you would save if you saved $5 in the first week, $10 in the second week, and you never touched it, and you did that all the way through the end of the school year. That's a decent amount of money. Now it's not going to like put you through college or anything, but you know, it starts off so easy. It's really not hard to do at the beginning, but at the end of your 30 weeks, it's a little harder because you got to do 150. The week before that was 145. The week before that was, okay, so anyway. All right. Any questions on this one? Okay. So that's how you make word problems out of these. And your homework looks like that. I have one last thing to teach, but not today, about these, and it is about infinite series. We'll do that tomorrow. So, sorry, I had so many examples ready. There we go. So we're going to do 9 and 10. A lot of people misread number 9. Let me look at it with you. Brian and Melissa saved $50 in the first week of a savings program. It's the same idea as what we just did a second ago. But again, they're not earning $50 a week. That would be really, you know, it's bad pay. They're saving $50 a week. So in other words, they might have earned $300 for the week, but they spent a lot of it. But they set aside $50 in the first week, $55 in the second week. So it's very similar to the one we just practiced. Okay. So you're going to do that one, this one, number 10, and this one. And that's got 2 parts. This is a reminder of these guys. Don't forget, you just put in 1, and then you put in 2, 3, 4, 5, 6, and the last one you put in is 7. Now, could you skip over finding all the terms? Yeah, you could. You could just evaluate it, but the directions do say write it in expanded form, which means I got to go in and get each piece. By putting in 1, I get 1/2. Plus, now I'm going to put in 2, and I get 1 squared over 2 squared, which is 1/4. Plus, dot, 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 dot. Just keep going. Write it out. That's what's expanded form means. Evaluate. I could just use that formula. A, 1 minus r over 1 minus r, and then that feels wrong, so you go, oh yeah, to the n. So you got to memorize that one? It's not going to be that bad. Okay, then I could put in the things I know. Amount to start with was, well, I put in 1 and I got 1/2, right? That was my first term. 1 minus r in this case, well, if as I look at this, it looks like this is a geometric. What did I times by? Oh yeah, I times by 1/2. Another way to do that is this divided by this, and it's 1/2, because 1/2 times 1/2 is 1/4. So that's r is 1/2. I put that here and here. And last but not least, n is the number of terms. And it says right here, we're doing 7. As long as it starts with 1, you can just trust that that's how many terms there are. If it starts with 0, you got to think about it. And you always get more numbers that way. It's like counting from 0 to 10 is actually 11 things. Don't forget that. Okay, so anyway, Number 4, I already did part of it for you here. There's one more. I want you to do number 10. You may skip 12 and any problem after that. It's not like it's a bad question. It'd be a perfect question to use for review. Part of me just wants to make that review sheet for you, but that's part of the growing up process. All your math classes from here up don't give you a review. The idea being that's a little too much spoon feeding you. You need to get used to taking notes and then realizing what the teacher said was important and then going back and doing your own review for your tests. Because in college, usually, they don't have, here kids, here's the practice test. It's not that way. We want you to do well in college. Okay. And that's all I've got for you for today. Tomorrow we'll talk about infinite and do some more stuff with word problems. And then there's just one more thing that I have to teach you. But the week's going to end. We're not going to have had the test this week. I might be able to make it work that the following week I would have it on that Friday. So, all right, that's all I got for you for today.